Okay.
How many questions we got here? Back?
I don't know. There's 14 on this test. All right. Oh, you know this is AP, so they throw little curveballs at you. Well, throughout your life of a math student, yeah. All right.
Boom test new. Wait.
What'd you just say?
Idea? Boom test new.
Oh,
Concept?
okay. Yeah, sure. Integrate. If we integrate this, what do we get? Y equals 10x squared. What type of an equation is that? Quadratic. I guess I should have multiplied by dx first, but integrate. Y equals. Come on! Thank you. That is linear. Integrate. Y equals 20 thirds x cubed. That is cubic. Y equals 5x to the fourth. That's quartic. Okay? So, do I care? No. The rate of change of received stimulus P with respect to the measured intensity S of the stimulus is inversely proportional to the intensity of the stimulus. So dP ds equals K over S. So dP equals 1 over S, or K times 1 over S ds, correct? Then what do we do? Integrate. So P equals K ln of the absolute value of S plus C. Okay, so be able to write that. Which of the following are solutions to that differential equation? What should I do? Crying is not an option.
Yes.
How about we take the first derivative of this thing? What's the first derivative of that? I feel like a failure. 2 times the cosine of 4x times 4, which is the same as 8 cosine of 4x. What's the second derivative of that? Because we have second derivative. Eight negative sine of 4x times 4, or negative 32 sine of 4x. Okay? If we put it into that equation, negative 32 sine of 4x minus 6 times cosine, 6 times 8 times cosine of 4x plus 8 times 2 sine of 4x. Is that going to equal 0? No, it's not. So do the second one. First derivative of the second one. is 3e to the 2x times 2, or 6e to the 2x. Second derivative of that is 6 times e to the 2x times 2, or 12e to the 2x. So then you take 12e to the 2x minus 6 times 6e to the 2x plus 8 times 3e to the 2x. See if that equals 0. Is 12e to the 2x minus 36e to the 2x plus 24e to the 2x 0? Sure is. So that one works. Now let's try CE to the 4x. What's the first derivative of CE to the 4x? Well, it's going to be 4CE to the 4x. What's the second derivative going to be? 16CE to the 4x. So it's 16CE to the 4x minus 6 times 4CE to the 4x plus 8 times CE to the 4x equal to 0. So it's 16 minus 24 plus 8 equals 0. Yes, so 2 and 3 only. Oh, which slope field would this thing be? What should we do? Well, if we put in numbers, like it's horizontal all along here. So at 2, 0, 3, 0, all those it's horizontal. So that would be y over x. So if you took, well, if the slope here is 2 times 0, this one works there. At 3, 0 it works. So let's try at -1, 1. It should be horizontal. Well, -1 times 1, is that horizontal? I mean, what's -1 times 1? It should be a -1. This is horizontal. Does that first one work? No. Okay. So the second one, 2 times 0 minus 0 is 0. So that works for this point here. So let's try this point here. -1, 1 is -1 times 1, which is -1, minus 1 equal to 0. So it's -1 minus 1. Does that equal 0? No. So that one doesn't work. Is -1 plus 1 equal 0? Yes, that works. And then this one is -1 plus a -1. Does that equal 0? No. And then this one, if we go 2, 0, that doesn't work. So it must be this one. So you just keep trying a couple points in here where they're obvious, and you just go until you find something that works. I mean, we should really test other points, like this point here should have a positive slope. So 0, 2 should have a positive slope. 0 for x, 2 for y makes a 0 plus a 2. Hey, that's positive 2 slope. That works. And so on. Uh-oh. All right. Slope field for this one. Does this look like the cosine curve? No, the cosine curve goes up and down and up and down and up and down. So that doesn't look quite right. Sine, tangent. I don't know if any of those are quite right. E to the x squared minus 1. So if we start at 0, e to the 0 is 1 minus 1 is 0. So that would make sense. And then you try the rest of the e's. So that might work. But actually, see how short this is? This only goes from 0 to 2. And if we go to 2 pi, that's like 6.28. So this could be the sine or cosine curve. Now the sine curve goes through like this and goes like this. So it's not that. So it definitely could be the cosine curve. The cosine curve, the normal cosine curve goes like this. Wow. Like this. Whoa. Like this. But if it's negative cosine, it would be going like this, right? So that kind of looks like the negative cosine curve because we're going down and then up. Okay, then you just keep trying numbers in and you'll see that it's that one. Okay, finding the general solution, what would we do first here? Separate the variables. Y dy equals 2x plus 3 dx. Integrate. 1/2 y squared equals x squared plus 3x plus c. Multiply both sides by 2. So y squared equals 2x squared plus 6x plus c. Then take the square root of each side. So y equals plus or minus the square root of 2x squared plus 6x plus c. Good? If we do this one, dy equals negative cosecant squared of x dx. What's the integral of negative cosecant squared? Cotangent of x, right? Plus c. What? Mm-mm. Because the first derivative of cotangent is negative cosecant squared. Okay. And then particular solution. So dy equals 4 cosine of x dx. Integrate. Y equals 4 sine of x plus c. We good? So 3 equals 4 sine of pi plus c. What's the sine of pi? What's the sine of pi? 0. Plus c. So c equals 3. So y equals 4 sine of x. For this one, y dy equals x squared dx. So if we integrate, what do we get on the left side? One half y squared. The right side, 1/3 x cubed plus c. So what do we do with both sides? So plus or minus 2/3 x plus c. Now, the initial condition is that. So y equals plus or minus the square root of 2/3 times 3 cubed, which is 27, plus c. Oh, not y, negative 2 equals that. So if we square both sides, 4 equals 2/3 of 27 is what? 18 plus c. So c equals negative 22. And since this is a negative, this would have to be a negative. Ooh, 22 should have been 14. Yeah, negative 14. Come on, Miss Bierschbach, do math. So, yeah, there we go. A student attempts this differential equation. Did they get it right or did they go wrong? Did they separate the variables correctly in step 1? Yep. Did they integrate properly in step 2? No. It's only when it's 1 over y is it the natural log. 1 over y cubed is y to the negative third. If you integrate it, it's y to the negative second with a negative 1/2 in front. Remember that? Make sure you remember that. Step 2 is where they went wrong. During 1 decade, the price of silver decreased at a rate that was proportional to the price of silver at the time. The prices of 1 ounce of silver was 22 initially, and it was $5.50 after 7 years. What's this going to be? Y equals C e to the k t. What's C? 22 e to the kt. So 5.5 equals 22 e to the k times 7. Divide by 22. 0.25 equals e to the 7k. ln both sides. ln of 0.25 equals 7k. Divide by 7. K equals the ln of 0.25 divided by 7. So y equals C. No. Y equals 22 e to the ln of 0.25 over 7 times t. And that's actually the answer. Now, if it said, what would it be when it was 25 years? Well, then we would plug 25 in for t. And that's the basics of what you'll see. So, there you go. You got one wrong?